All right, we're going to start with chapter 4. But this is going to be section 2, but I'm going to go back over some things from section 1 just to refresh your memory about polynomials in particular. So recall that a monomial is a number like 12, or a variable like x, or the product of a number and one or more variables like 12x, or 12xy, or 12a squared b to the third c to the fifth. That whole thing, everybody multiplying together, is a monomial. A polynomial, poly meaning many, is made up of monomials, mono meaning one, so more than one is going to be many, okay, where all the exponents are whole number exponents, so no radicals, no fractional exponents. They've got to be whole number type stuff, even positive. They can't be, flipped over on the bottom or whatever. So your variables can't be in the bottom, okay? Your important things about it, things like the degree. The degree is the exponent numbers on the monomial. So, for instance, get my pen back out here. If we had 12x squared, then the degree is 2. If we have 12x squared y to the third, the degree would be 5. You actually add 2 plus 3, making the 5. So it totals up all of the exponents of all the variables on the monomial. The degree of the polynomial is the highest degree monomial. And what we do is we put the polynomial in standard form. It's where the terms are written in descending order. So if you look down in this zone right here, you can see that it's to the third, to the second, and then it would be to the first. It's to the second, it's to the first, it's to the none. It's to the first, it's to the none. And then there's, that one. Even with the very bottom one, where it's to the fourth, and then to the first, and then to the none, it's still 4, 1, 0. They count down and descending. That's standard form. You have to know the degree of every monomial, and then you put them all in order. The highest one is the degree of the whole polynomial. So the reason that x to the fourth plus 2x minus 1 down here at the bottom, the reason that that is a degree of 4 is because the biggest one is x to the fourth, so it is a degree of 4. When they are in standard form, then you have something called the leading coefficient. That's in the lead is to be in front. That's the number in the very front of the polynomial. So the leading coefficient on this one, there isn't really, because there's not a thing in front, but you could say it's negative 14. But here, be 5, be 2, 1, and 1. Okay, so things to know and remember about polynomials. We're not really looking too much into their graphs, but here's some generalized ideas about the graph so that if you have a polynomial equation, you can get a general idea of what its graph's going to look like. That helps you on quizzes and tests that are multiple choice where the picture's there. Or if you have a picture of the graph, you get an idea of about what its equation is going to look like. At least what its leading coefficient might be, what degree it is, all of those kinds of things. So when we're talking about the graphs, we're talking about their end behavior, what the arrows that you draw on the ends of the lines that go forever and ever are doing, the ends, okay? Two main styles. If the degree is odd, our first two pictures here, left and right, the ends go in odd directions. One goes up, one goes down. One goes down, one goes up. Which way they point depends on the leading coefficient. If it's positive, the graph will have an overall positive tendency. So it will go from left to right, being starting it down and going to the up position as it goes that way. If it's negative, it's going to have an overall downward position, starting high, going low. This terminology that I have here by these graphs, f of x arrow negative infinity as x arrow negative infinity, they're describing how the graph is moving. Remember, f of x is just y. I usually say these in a different order. I usually talk about it in terms of x and then in terms of y. I would say as x approaches, that's what that arrow means, approaches negative infinity, then f of x, or y, approaches negative infinity. And all that is saying is that as x goes to the left, y goes down. As x goes to the right, y goes up. And it's backwards over here. As x goes left, y goes up. F of x goes up. As it goes to the right positively, it goes down negatively. Okay. If the degree is even, then the arrows are going to go evenly. They go the same. Okay. Not parallel, but they go in the same direction, not in different or odd directions. If it's positive, it's going to point up. If it's negative, it's going to point down. Another thing the degree can tell you is how many solutions there are. If the degree is a 3, it will have 3 solutions. So it should touch the x-axis in 3 places. Or it would touch the x-axis in 1 place and then 2 imaginary places. Any imaginary answers with polynomials are going to come in pairs, a positive and a negative. It's going to come in 2s. Okay, so you'll have that. If it's even, like the one we have pictured, this one has 2 places that it touches. So I know it's at least a degree of x squared because it has to be even because they go the same direction. I know it's going to be actually 4 because there are 1, 2, 3 turns. 1, 2, and 3. Okay? So the degree is 1 more than the number of turns, or the number of turns is 1 less than the degree. So I've got 1 direction and then I change. I've got 2 directions, it change. I have 3 directions, I change, and I have 4 directions. So I know that's going to be an x to the 4th degree. I know that I have 2 real and 2 imaginary because there's 2 real answers there where it crosses the x-axis. It has to have 4, so there's got to be 2 imaginary. So that's just some things about polynomials. Now let's get into what we're talking about today. Adding, subtracting, and multiplying. This is what 4.2 is all about. And adding and subtracting is all about like terms. Like 3 bananas plus 5 bananas makes 8 bananas. But 3 bananas plus 5 oranges still only makes 3 bananas. You don't put the 3 and 5 together because they're not like terms. It's the same thing for x's, x squareds, constant numbers, and above. So let's look at adding. Now they do it in 2 different ways. They do vertically and horizontally. Now with adding, you're probably familiar with vertically. It would look something like this: 217 times 28, or plus 28. And you just add in the columns. What you don't really realize you're doing is you're doing 200 plus 10 plus 7, and you're adding it to 20 plus 8. And so you've got the ones, tens, and the hundreds. And you're adding them in columns. You're doing the like terms. 7 and 8 are like each other, they're ones. 10 and 20 are like each other, they're tens. 200 isn't like anything, so you don't put it with anything. That same thing happens. We're going to do that, but with variables involved. So let's look at A. 3x to the third plus 2x squared minus x minus 7. And I'm going to add x to the third minus 10x squared plus 8. Okay, and so I'm going to add them together. Now notice, and I'm going to do it a different color, I didn't do anything right here. You could put plus 0x. There's no x in the polynomial, so I just skipped that spot so that everybody lines up. The constants, the x's, the x squareds, the x to the thirds. Make sure you line them up so you don't misadd coefficients. Now it doesn't matter if you go left to right or right to left because they're not going to carry over. So I'll do left to right. 3x to the third plus 1x to the third is 4x to the third. 2x squared negative 10x squared is negative 8x squared. Negative x and nothing is negative x. Negative 7 and 8 is positive 1. Works the same if we do it the other way. Now they also do a horizontal version. So you got 9y to the third plus 3y squared minus 2y plus 1. That whole polynomial plus negative 5y squared plus y minus 4. That whole polynomial. Here you got to just do like terms. This saves more space, but is a little bit harder to see. Vertically takes up more space, but is way easier because they all line up. I've had students in the past mark the things that are like terms. So like I know this is a y to the third, so maybe mark it with 3 lines. Y squared with 2 lines, y to the first with 1 line. Don't mark the constant. This one's got 2, that one's got 1, so I can kind of match them up. It's not too hard when it's one variable to exponent, but when we start doing double variables and things, it's a little easier if you do that. I've seen some people do circles and squares and triangles and other stuff around the numbers so they know which one is which. You just got to find your system. So 9y to the third plus, there aren't any not y to the third, so it just stays right there. That's supposed to be to the third. There we go. And once I use it horizontally, I like to scratch it off so I don't use it again. 3y squared minus 5y squared is going to be negative 2y squared. And I use those. Negative 2y and positive y is a negative y. And 1 and negative 4 is going to be negative 3. And there's our answer. I don't care which way you do it. The book may tell you to do it one way or do it the other. Do it whatever way is the easiest for you to get the right answer the quickest. If you like vertical, go for it. If you like horizontal, go for it. I don't care which. Now, when we get to subtraction, I like their note here. To subtract one polynomial from another, basically they're saying don't. They want you to add the opposite. You might have heard this as like keep, change, change. This is just on a bigger scale. We keep all of the first polynomial, we change the middle sign, and then we change all of the signs in the next polynomial. Now, the way they have these written in words, the way you would actually do them gets a little confusing. They want us to subtract 2x to the third plus 6x squared minus x plus 1 from 8x to the third minus 3x squared minus 2x plus 9. That means this one goes first, and we want to subtract this one. So when I write this, and I'll do this one vertically like they ask, I'm going to write 8x to the third minus 3x squared minus 2x plus 9 first. And then I'm going to subtract, and I'm going to put it in parentheses, and I'll show you why in just a second. 2x to the third plus 6x squared minus x plus 1. Now, the reason I put it in parentheses is because you can kind of act like this is a negative 1, and you're going to distribute it to everybody on the inside, okay? Oop. And so when I do that, it's going to change this sign. So I keep all of the top one, I change, and then I change all of the ones inside. Now when it's an addition, I don't have to worry about going through that negative symbol. I just have to go straight down. So 9 minus 1 is 8, and it's positive. Negative 2 and 1 is negative 2x, and positive x is negative x. Negative 3x squared and negative 6x squared is negative 9x squared. And 8x to the third minus 2x to the third is 6x to the third. And it works just like that. It goes similar if you use, and I'll use blue this time since I got red and green in the other one. We're going to subtract this. This is the takeaway from that. So I'm going to go 2z squared plus 3z minus 3z squared plus z minus 4. And I'm just going to distribute that negative all the way through. So I'm going to keep the first parenthesis, and then I'm going to change everybody on the inside. Now just do like terms. That's got 2, that's got 1, that's got 2, that's got 1. So put my 2's together. 2z squared and negative 3z squared is negative z squared. 3z and negative z is positive 2z. And nothing and 4 makes 4. And there's our answer. All right, here's a couple for you to try. Find the sum or find the difference. Number 1 is find the sum. Number 2 is find the difference. You don't have to worry about the weird word thing where you have to rearrange them. They're already set, this one minus that one on number 2. So give it a pause right now, try these, and come back and see how they go. All right, here we go. I like doing them horizontally. They're already set up that way, so I'm just going to mark them. That one's got 2, that one's got 1, that one's got 2, that one's got 1. 2x squared and 7x squared equals 9x squared. Negative 6x and negative x is negative 7x. And I use those, and I use those. 5 and negative 9 is negative 4. Now with the subtraction, I'm going to change the 5, I'm going to change the t squared, and I'm going to change the 17. Now all I have to do is like terms. 3, 2, 1. 3, 2, 1. So 3t cubed and negative 5t cubed is negative 2t cubed. Use that one, use that one. 8t squared and a t squared makes 9t squared. There aren't any other t's, so I'm just going to carry that negative t over. And negative 4 and negative 17 is negative 21. Ooh, hello. And there's my answer. That's all there is to adding and subtracting, just like terms. So on the subtract, just distribute it all the way through, keep, change, change, work your way through. Now let's talk about multiplying. The key to multiplying is each term in the first polynomial by each term in the second polynomial. Everybody times everybody. We've already done this a bit with binomial times binomial. We've done FOIL, first, outer, inner, last. This is the same deal, just on a grander scale. Everybody times everybody. You can do it vertically or you can do it horizontally. Now vertically, we can bring back our 217 times 28 thing, and now we just do times, and we want to do a dot instead of an x because x is going to be a variable, and it'll just get messy if we have multiple x's on there. But you remember how to do this. 7 times 8 is a 56, so you put the 6, carry the 5. 8 times 1 is 8 plus 5 is 13. 8 times 2 is 16 plus 1 is 17. And then you zero out the ones place, and you go with the tens. So you start in the 10 zone. 2 times 7 is 14, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. And then you add down. 6, 7, 10, 60, 76. That's how it goes. Okay? So we're going to do the same thing, but with polynomials. So negative x squared plus 2x plus 4. And we're going to do an x minus 3, and we're going to multiply them. Your first term is your minus 3. So negative 3 times 4 is negative 12. Negative 3 times 2x is negative 6x. And negative 3 times negative 2, negative is positive. 3x squared. I'm going to zero that out. Put in my 0 there. Now x times 4 is 4x, and it's positive. X times 2x is 2x squared, and it's positive. And x times negative x squared is negative x to the third. And then just add down. Negative 12. Negative 6 and x and 4x is negative 2x. 3x squared and 2x squared is positive 5x squared, and you got negative x to the third. There you go. That's not my favorite way to do it. That's not how I grew up doing it. I didn't do vertical. I didn't think about it till this book, actually. But horizontal is my game. Y plus 5 times 3y squared minus 2y plus 2. I think I did it horizontally mostly because it was a paper saver. And that was just how it was shown. But everybody times everybody. So the y times the 3y squared is 3y to the third. The y times the negative 2y, negative 2y squared. The y times the 2, 2y. 5 times the 3y squared is 15y squared. 5 times the negative 2 is negative 10y. 5 times positive 2 is positive 10. And do your like terms. 3 of them, 2, 1, 2, 1. So 3y cubed. Negative 2y squared and 15y squared is positive 13y squared. 2y and negative 10y is negative 8y. And then the 10 carries down. There's your answer. We also looked at one other way that I will show you, and that was the box. I think the box is probably the cleanest. It's a little bit of vertical, it's a little bit of horizontal, and it's really easy to see. You just take one term of the polynomial and put it on each side of the box. So I got a y there, I do a plus 5 here. My next term had 3 pieces in it, a 3y squared, a negative 2y, and a 2. And I'll even put the plus sign there so it just looks like that polynomial. Then whatever's on the side of the box you're in, that's what you multiply. So y times 3y squared is 3y cubed. Y times negative 2y is negative 2y squared. Y times 2 is 2y. 3y squared times 5 is 15y squared. Negative 2y times 5 is negative 10y. And 5 times 2 is positive 10. Here's why I like the box method. The diagonals are like terms. It puts it in a nice, clean way to see which things you add together. Redo yellow. Those guys. Okay? So, the 3y cubed gets written down. The 15 and the negative 2 goes to 13. The negative 10 and the 2 goes to negative 8. And then you got a 10. And it works just like that. Okay. The last multiplier we're going to look at is just the next level up, which is just more multiplying. Okay. Not any harder, it's just more work. Here, they want us to take x minus 1 times x plus 4 times x plus 5. They want us to multiply 3 things together. Well, the easiest way to do that is 2 at a time. So that's what you should do. And here's what they're telling us. We've seen this before when we had a x minus something in a parenthesis and an x minus something in a parenthesis. Those were what x equals. Remember, we could opposite to get out. So x was 1, x is negative 4, x is negative 5. What that is actually telling us is that the graph crosses at 1, at negative 4, and at negative 5. It's going to touch in those 3 places. Since it touches in 3 places, that's kind of telling me it's going to have a degree of 3. And then I'm going to have arrows that point in opposite directions. But let's do the math and double check. Just start with the first 2. X times x, x squared. X times 4, 4x. Negative 1 times x, negative x. Negative 1 times 4, negative 4. And just bring down the one we haven't done yet. These are like terms. So x squared plus 3x minus 4 times x plus 5. Now everybody in here times everybody over there. X squared times x is x to the third. X squared times 5 is 5x squared. 3x times x is 3x squared. 3x times 5 is 15x. Negative 4 times x, negative 4x. Negative 4 times 5 is negative 20. 3 things, 2 things, 2 things, 1 thing, 1 thing. Oh, they're right next to each other. So x to the third plus 8x squared plus 11x minus 20. It was a degree of 3. Its coefficient, leading coefficient, is a 1. So I know it ends up going upwards. That means it starts going downwards. And it has to cross in between these guys, something like that. I don't know that that's how high the hill goes, and I don't know how that's how low the valley goes, but it goes something like that. All right, that's all for this first video of 4.2. We'll get into the patterns of multiplying in the